So hello friends, Shivansh this side, and today I'm gonna share a paradox with you of mutual inductance as a topic. So question is, this is a very big disk, this is a very small disk, this is of R1, this is of R2. We have to find mutual inductance of the system. So just to define what mutual inductance is, if we due to EMF in it, due to current in it, EMF is produced in this thing. So that means phi d phi by dt is m times t, like phi is Li, phi is m I2, phi in 1 is m times I in 2. Okay, and very nice coincidence is that phi 2 is m times I1. That means this m is mutually same for both. This is a very nice thing. It's of course not a mere coincidence and can be proven. Sorry, it can be proved. But anyways, so how to find the mutual inductance? First step is pass current in any loop. Pass current in any loop. Second step is find corresponding flux in other loop, the loop in which not the current has not been passed. Then compare with this equation. Okay. So according to the convenience, if we pass current in bigger loop, we will get answer easily. So we are here pass current, any current, let's say I1. We are passing current here I1. Okay, so find corresponding flux in loop 2. This is loop 2. Okay, this is first loop, this is second loop. So for flux in second loop, pi r1 square into b mu naught I by 2r, mu naught I1 by 2 r1, sorry hi mu r2. This is flux. I will explain that how we got this term, but anyways, phi in 1 is phi in 2 is m into I1. I1 get cancelled and we get mutual inductance at pi r1 square by 2 r2. Okay, and now let me explain how we get this. Flux is basically b into a, and for this circular loop, the flux b at center is mu naught I by 2r. To prove it, you can simply use Biot-Savart law, or if you know that this formula, axial one, mu naught I r square by 2x square plus r square to the power 3 by 2, put x is 0 over here, you will get the same formula. Okay, and here because loop is very small, we are considering it as mu naught I by 2r. Okay, so an area of the loop is pi into r1 square, and using this equation we compared, we get this as mutual inductance. Now what paradox is that? Like, not a kind of paradox, it's a strange thing that if I pass current in this small loop and try to locate flux in the bigger one, then the thing goes pretty complicated, but let's try to trace it. Okay, so first of all, by radial symmetry we can say that in this region, like in this small disk element, the field would be same. The field would be radial kind of thing, dependent on distance from the center. Okay, so let it be like, so it would be same in this area. So finding corresponding flux, we have to integrate all the flux elements on these disk. It is at distance x, area is 2 pi x dx, and for field I am gonna use magnetic formula of magnetic dipole at distance x. If it is a magnetic dipole, so like its magnetic moment is in z direction, so all xy plane are its equatorial plane, is in its equatorial plane, and hence we have formula mu naught m by r cube minus also mu naught by 4 pi m. Okay, so just directly using it, mu naught m by 4 pi x cube 2 pi 2. Okay, here we get mu naught m, this is x square, mu naught m, integral is something negative is here, negative from here will get cancelled, mu naught m by 2x. Okay, and what is m? M is magnetic moment of this loop, small loop, which is what IAN, which is IAN. What is I? I is I, anything, because it's gonna cancel due to this proportionality. So let's ignore I. A is pi into r1 square. Putting pi into r1 square, x is integrated all over from r1 to 0. And this is a strange thing, that if I ignore 0 term, or simply if I take it from r2 to infinity, my mutual inductance is from r2 to infinity, then I get the same mutual inductance but I'm getting inside of this thing. Like I'm saying, I'm integrated it from r2 to infinity. That means mutual inductance of system like something like a infinite loop over here at infinity which ends here kind of thing. And this is almost, not almost, it's exactly the same. Is it just a coincidence or something is there? So please answer in comment. Looking forward for your responses. Thank you. Have a nice day. Please subscribe the channel.